So now that we know, or at least we've got them categorized and we've gone through the first layer of the bubbles, let's take a deeper look. So the 18x squared minus 30x and the 14x minus 7. These two fall in the GCF category only, and here's why. When I factor out the GCF of the 6x and this 18x squared minus 30x, inside my parentheses, I have a 3x minus 5. So we want to make each factor as low as we can go. It's like reducing a fraction. Is it the lowest it can go? So I'll look at what I have left in the parentheses. And now notice how I've got two terms here. So I'm going to follow this flow of my bubble. Two terms. And so I'm going to go through my checklist. I've got two terms, so could it be a difference of squares? Well, you want to look for two terms. I have that. Is there subtraction between them? Yeah, there is. But I have a bx, and also 3x and 5, they're not perfect squares. So this is as low as it can go. It's completely factored. My factors are 6x and 3x minus 5, and I can't go any further with that. So the 14x minus 7, we said it had a GCF of a 7. So I'm going to factor out the 7. When I do, inside my parentheses, I have a 2x minus 1. So again, let's make sure that I'm completely done. So I have two terms. So I'm going to follow this bubble. Then I definitely have subtraction between them, but I have a bx. And 2x is not a perfect square. 1 is, but 2x is not. In order for it to be a difference of squares, they both have to be perfect squares, and they're not. So this one is completely factored, and that's as low as it can go. So this is what it would look like in terms of your final answer. 7 is a factor, and then 2x minus 1 is a factor. Now let's look at the 4x squared minus 25. So in this one, I do not have a GCF, even though the bubble says first look for. So if I don't have a GCF, then I'm going to go ahead and go to the next layer of bubbles, or the next level of bubbles. So I have two terms. So now I'm going to follow this bubble. And now that I have two terms, go through your checklist. Two terms, so it's a binomial. Is there subtraction between the two terms? Yeah, there is. Is there missing a bx? Yeah, there's no bx. And are both terms perfect squares? So the answer is yes. 4x squared is a perfect square, and 25 is a perfect square. So this one has to be the 4x squared minus 25. And so on my foldable, now that I have the no GCF, two terms, subtraction, perfect squares, remember how we set up the opposite factors called conjugates. The square root of 4x squared is 2x, and the square root of 25 is 5. So 2x plus 5 is a factor, and 2x minus 5 is a factor. And I'm looking at each of these, and they are as low as they can go. I cannot break them down any further. So I'm finished. This one is factored, completely factored. So now the next step. So in these two examples, the first one I had a GCF of an x squared. So when I factor out an x squared, notice inside my parentheses how I have an x squared plus a 14x plus a 49. And then in this example, 2x squared plus 14x minus 60, notice how I had a GCF of a 2. So when I factor out the 2 inside the parentheses, I have an x squared plus a 7x and a minus 30. So are they completely factored? Well, notice how I've got three terms. And so I'm going to follow my three-term branch. And then from there, notice how they fall in this category of the x squared plus bx plus c. X squared, bx, c. X squared, bx, c. So now I'm going to follow this branch. For this one, we can find the factors of c that add to b. So factors of 49 that add to 14, or factors of negative 30 that add to 7. So let's see what these two look like. So I can factor them down further. And so with the first one, factors of 49 that add to 14, well, that would be 7 times 7 is factors of 49, and 7x plus 7x adds to 14x. So this one has three factors: x squared, x plus 7, and x plus 7. Now in the next one, once we factor out the 2, we're looking for factors of negative 30 that add to 7. And so my factors of negative 30 that add to 7 is 10 and negative 3. And when I combine them, we get 7x. So 2 is a factor, x minus 3 is a factor, and x plus 10 is a factor. And now the last example. So the last set of 3, they all fall under the category of the trinomial ax squared plus bx plus c. Even with the first one, when I factored out the GCF of the 2, notice inside the parentheses how I have a 2x squared plus 3x minus 20, or the ax squared plus bx plus c. And so I have 3 terms, ax squared plus bx plus c. So now what I want to do is I want to find factors of a times c that add to b. So factors of 2 times negative 20 that add to 3, or factors of 6 that add to 7, or factors of 30 that add to negative 11. So let's see how these 3 look. So I'm going to go to my foldable. I'm going to look at the factoring quadratic trinomials, the ax squared plus bx plus c. And the first one, like I said, we factor out the 2. This is still factorable. So remember, you multiply the 2 and the negative 20. So factors of negative 40 that add to 3. And the set that works is 5 and 8. Only the 5 has to be negative. And so, again, this time we're working inside out. So we place the 8x and the negative 5x inside the box, and then we start looking for GCFs. This one is factors of 6 that add to 7. And so when we find that, looks like the only ones that it can be is 1 and 6. So again, inside the box is going to be a 1x and a 6x. And then you start factoring out GCFs of each one. So here we have a GCF of a 3x. And then once we factor out, once we get it started, the rest just sort of fills itself out. And then the last one, factors of 30 that add to negative 11, looks like it's going to be negative 5 and negative 6. So I hope this has been helpful. You can watch the other videos if you need extra examples on how to factor, breaking these down even further. But I hope this was helpful in knowing where to start. So factoring, being able to use that flow chart, figuring out which layer of bubbles you're going to follow, and then from there, figuring out, okay, I'm going to use this part of my foldable.